The first F-15 designed for long-range interdiction missions as well as air superiority is being flight tested by McDonnell Douglas and the U.S. Air Force at Edwards Air Force Base in California. Designated F-15E dual-role fighter, the Air Force plans to buy 392 F-15Es to perform long-range, heavy payload ground attack missions as well as serve in the traditional air superiority roles. Let's listen as Irv Burrows, the first pilot to fly the original F-15 in 1972, takes us through an in-depth briefing on this latest addition to the Eagle's Nest.
In the 14 years that have passed since first flight, the F-15 Eagle, built by Mac Air, has dominated the skies of the world as the Air Force's air superiority fighter. And in this role, the Eagle will continue to defend the United States and our allies for many years. This new breed of Eagle, the F-15E, will retain that capability, but it is also designed to strike high-value ground targets in night and in poor weather. Its new mission, long-range interdiction, requires large payload capability as well as outstanding air superiority characteristics. Let's look at some of the changes that have been made to the Eagle, which is being displayed here. 60% of the airframe has been changed to make it stronger, giving the F-15E the ability to take off with a gross weight of up to 81,000 pounds and sustain a 9G load factor throughout its flight envelope. The same structural changes will extend its life expectancy to 16,000 hours of flight, or twice that of the earlier F-15s, and it will be able to carry up to 24,500 pounds of weapons. The low-drag conformal fuel tanks will add about 9,000 pounds of fuel. These tanks will carry weapons on stub pylons rather than on conventional carriage racks, reducing drag and thus stretching the range of the Eagle. That's just the airframe. The F-15E, as well as some recently delivered Cs and Ds, will be powered by two new Pratt & Whitney F-100-220 engines, which incorporate the latest in digital technology to provide better performance and better maintenance. Those of you who've seen the F-15 perform in air shows may find it hard to believe that it can accelerate faster or maneuver better, but that's what will happen with these new engines. For example, with a digital electronic control system, the F-15 pilot can accelerate from idle power to maximum afterburner in under 4 seconds, 40% faster than they could with the previous engine control system. Faster engine acceleration means quicker takeoffs and crisper response while maneuvering. The new engine is more maintainable as well. The digital system's components were designed with externally mounted modules that can be changed without removing the engine. This modular system has reduced the number of man-hours required to maintain the power plant by more than 50%. A system that automatically trims the engine will eliminate costly trim runs and result in a 6% savings in fuel costs. In addition, the 220 engine has an engine monitoring system that records engine data and faults, eliminating the need for manual tracking. It will substantially simplify engine troubleshooting and repair. And for the future, the F-15E has a new technology engine bay designed to accept other engines which may be desired to meet developing requirements. Mac Air has blazed a trail for the aerospace industry in developing a very sophisticated process called superplastic forming and diffusion bonding to help make this new engine bay. The process allows us to form larger parts from single pieces of metal, which reduces the number of fasteners and overall weight of the airplane at a lower manufacturing cost. To help guide the F-15E's crew over long distances in darkness and poor weather, several new avionics systems have been incorporated. The new inertial navigation system, developed by Honeywell, uses a highly reliable ring laser gyro to continuously determine the aircraft's position and provide that information through the computer to the various systems and displays in the cockpit, including a new moving map. This new system will feature reliability on the order of 10 times that of its forerunner. The Hughes APG-70 radar will find the target at long ranges. For example, from more than 80 miles away, at low altitude, the crew will be able to pick out bridges and airfields on the radar display. Nearing the target, the resolution becomes greater, and smaller targets, such as vehicles, are easily detected. The high-resolution radar is designed to create and freeze the maps during quick sweeps of the target area so that it may be shut down for much of the penetration portion of the mission, thus minimizing the opportunities for detection from enemy defensive systems. The E-model pilot will fly the aircraft with a new digital flight control system created by Lear Sigler. This system will feature an automatic terrain following mode, which will use information from the Lantern radar, and at the pilot's option, control the Eagle without pilot input at low altitude and at high speeds. For increased safety, the system will be triply redundant. The addition of these improvements will enable the F-15E to deliver weapons at night and in poor weather as accurately as today's best attack aircraft can in the daylight. These new systems will be manageable thanks to a complete update of the F-15E pilot's cockpit, but the most important addition to the F-15E is the new rear cockpit designed specifically for a weapon system operator. On 4 cathode ray tubes, the operator can display information from the radar, electronic warfare, or infrared sensors, monitor aircraft or weapon status and possible threats, select targets, and use an electronic moving map to navigate. 2 hand controllers are used to select the new displays and to refine the targeting information. Displays can be moved from one screen to another and are chosen from a menu of display options. In addition to the 3 similar tubes in the front seat, the pilot has a transparent glass screen called a heads-up display, or HUD, in front of him at eye level that displays vital flight and tactical information. As in all earlier F-15s, the pilot can select his weapon options and displays with switches mounted on the stick and throttle and without having to look into the cockpit. Already the safest fighter in the United States Air Force history, the new version of the Eagle will provide a long-range ground attack capability without sacrificing its ability to survive, since it will retain all its air-to-air weaponry as well as its speed and maneuverability. Protection from ground-based threats is enhanced by the triply redundant digital flight control system, self-sealing fuel feed tanks and fuel lines, fire-retardant foam in the fuel tanks and voids, and a strengthened structure. Electronic protection is provided by an integrated internal tactical electronic warfare system. This system includes a radar warning receiver and active electronic systems designed to deceive enemy sensors. To confuse enemy infrared missiles, flares can be released and chaff can be expended to deceive enemy radars and disrupt radar-guided missiles.